Hi once again. In this video, we're going to talk about exponential function. We have been talking about various type of functions. Now in this video, we will be talking about the exponential function. Extremely important function, of course. Exponential essentially means a to the power x. Okay, so and think that when x comes in power, so essentially, what is happening that if a is a positive real number, anything else, anything other than unity, okay, anything other than 1, then a function that can associate a real number x, okay, a function that can associate a real number x to ax, a to the power x, okay. So if a is a positive real number other than unity, then a function, a relation that can associate each x belonging to the real number, the set of real numbers R, each x belonging to R, to a to the power x. Okay, so this time my function looks like a to the power x. Okay. That is called exponential function. That is called exponential function. Okay, that means that the number a, okay, that positive real number a is growing exponentially, okay, with various real number x can take, okay, so a to the power x. So fx equals to, so f is a function from R to R, right? The domain contains all x, so that will be a real number. So a to the power x also comes out to be a real number. Okay, so R to R is the domain and code domain of this function. Fx equals to a to the power x, where a is greater than something that I haven't written. A should be greater than 0 and not equal to 1. So what will be the domain? Domain can be any real number. Domain can be any real number. Okay, domain can be any real number. And ax, so what will be the range? Range would contain all a to the power x's, right? So a to the power x's, so that means ax will be positive. So r plus or 0 to infinity. The domain can be the set of all real numbers, but because a is positive, a is greater than 0, so your range will be a positive number. Okay, now a is greater than 0. Okay, a is greater than 0. Let's see basically what this function can look like. What will this function exactly look like? So a is greater than 0 and should not be equal to 1. That is one condition that we know. So we can have various cases, right? So the very first case that comes into our mind, what happens when a is greater than 1? Strictly greater than 1. What happens when a is strictly greater than 1? Okay, then y equals to fx, which of course equals to a to the power x. So can you see, for increasing value of x, what do you think? Fx will increase or not? Of course. So a to the power x increases as the value of x increases. Okay, a to the power x increase as the value of x increase, right? So as x increases, a to the power x would increase, right? Now, what exactly can ax look like? Ax would actually be less than 1. We are taking a as greater than 1. We're taking a as greater than 1. So ax will be less than 1 when x will be less than 0, right? X can be negative. Domain will have all sort of elements. And it will equal to 1 when it is 0, x is 0. And what will happen? It will be greater than 1 when x is greater than 0. Okay? So let's see on the graph what exactly it looks like. what exactly it looks like on the graph. Okay, so 1 is a point. Okay, so 0, 1 is a point. Why 0, 1? Because when x is 0, y is 1. A to the power x is 1. Okay. Now, as I said, with x increasing, ax will be increasing, right? With x increasing, ax will be increasing because a is all positive. A is positive. So, increasing. So, this is what the function will look like. It will, touch the axis at 0, 1 because when x is 0, y is 1. Okay. Now, this will increase. For increasing value of x, you will have increasing value of a to the power x. I mean, we can look at some numbers for that matter. Okay, you can imagine some numbers. 2 to the power x. Now, 2 to the power x for whatever x greater than 1. So 2 to the power x, 3 to the power x, 4 to the power x. When x is greater than 1, it can be 1, 2, it can be 2, 3, or so on and so forth. So let's look at the relationship between 2 to the power x, 3 to the power x, 4 to the power x, and so on. So when x is greater than 1, what do you think 2 to the power x and 3 to the power x would be? Say x is 2, then 2x, 2 to the power x will be less than 3 to the power x will be less than 4 to the power x. Okay. Anything you can think of, any number. So for increasing x, this is what the relationship will be. For increasing x, this is what the relationship. When x is 0, everything is 1. So it will be equal. Okay. And when x is less than 1, okay, say 1 by 2 or anything, then 2 to the power x will be greater than 3 to the power x will be greater than 4 to the power x. Okay. So it's always good to put in some numbers and then see what exactly we're talking about. Okay, now next case. So we've seen the case when we have taken a to be greater than 1. Now let's take the case where a is between 0 and 1. So y equals to a to the power x. Y equals to a to the power x. Now think if it's a fraction, right? So a is a fraction between 0 and 1. Think of any fraction. You can think of half or anything between 0 and 1. So now a fraction to the power x, and when x is increasing, that fraction will decrease. Why? Because the denominator will increase. The denominator increases, the fraction decreases. So a to the power x decreases as x increases. Okay, so that's the relation between ax and x. When a is between 0 and 1, when a is a fraction between 0 and 1, then a to the power x clearly will be greater than 1 when x is less than 0. When x is less than 0, it will be greater than 1. Of course, when x equals to 0, it's going to be equal to 1, as usual. Anything, to the power 0 is 1. And it will be less than 1 when x is greater than 0. It will be less than 1 when x is greater than 0. Okay, so that's how it's going to be. Let's graph it. Let's graph it. Let's see what it looks like. Let's graph a bit of this exponential out here. Okay, so 0, 1 is an important point. 0, 1 is a very important point because when x is 0, we know that y equals to 1. Y is a to the power x. So that equals to 1. So in this case, what will happen is that, your ax decreases as x increases. Your ax decreases as x increases. So it is falling down, down, down like this. Okay, cutting y-axis at 0, 1. Cutting y-axis at 0, 1, it is falling down, down, down. You know, you can think of any number for that. You can think of numbers like 1 by 3, 1 by 2, 1 by 4 to the power x. So for various x's, what will be like 1 by 2 to the power x? It will be decreasing. 1 by 3 to the power x, it will be decreasing with, you know, with the x increasing. So you can think of values, you know, which are fraction, 1 by 2, 1 by 3, 1 by 4, as I said. So these are all values between 0 and 1, right? So 1 by 2 to the power x, 1 by 3 to the power x, 1 by 4 to the power x. Now, these all will have a decreasing graph. These all will have a decreasing graph. Now, say x equals to 2. So then 1 by 4, 1 by 9, 1 by 16. Now 1 by 4 is greater than 1 by 9, which is greater than 1 by 16. See, because the denominator is increasing, as I said, so the fraction is is as such decreasing, right? So as x increases, fx is decreasing when a is a fraction between 0 and 1. And in fact, I can probably, you know, just think of just 1 by 2 and just increase. Do not vary a, only vary, only vary x. Okay, so 1 by 2 to the power 2, 1 by 2 to the power 3, and so on and so forth. So the fraction will keep on decreasing. Here we have, you know, compared with different a's, okay, but with the same a. So half to the power 2 is 1 by 4, half to the power 3 is 1 by 8. 1 by 8 is smaller than 1 by 4. Okay, so on and so forth. So now special case, let's talk about e, the exponential e. Now e is a value between 2 and 3. E is a value between 2 and 3. So therefore, the graph of ex will be similar to, will be in fact identical to ax for a greater than 1, the earlier one, where the values of the function were increasing with x increasing. So an increasing graph. Ex is between 2 and 3. So it is strictly greater than 1. So the first case is for exponential, ex. Right? For ex, this will be the case, and for e to the power minus x will be the opposite case. So the second case will be for e to the power minus x. I mean, that's just some extra knowledge that I'm throwing in. You could probably think more about it. And then later on, we will look at exponential and logarithmic, relationship. So in the next video, we'll talk about log, which is quite related to this. Thank you.